Alright, this says use analytic methods, which just means use calculus and like without a graph, to find the extreme values of the function on the interval and where they occur. So this function is restricted to that interval, so that's one thing. And we're going to find the minimums and maximums. So here's something that I want to say before I get started. If I have a relative minimum or a relative maximum, those occur when the derivative equals 0. Those are horizontal tangents. So if I wanted to figure out where the derivative is 0, I can take the derivative and I can set it equal to 0. So that will help me find those x values there. Or like I might have something where the derivative is undefined. Something happens where the derivative is undefined, and I'll see if there's like I don't know, some kind of asymptote or some kind of discontinuity. Maybe it's closed off. I don't know. We'll see. But here's what I'm thinking for e to the negative x. What does that look like? I'm thinking, so I'm trying to think ahead. So none of this has to do with our actual problem, but I just want to think ahead and try to explain it completely. So what does e to the negative x look like? Normally, e to the x would be like this. If you make the x negative, that switches, I think, around the y-axis. So it kind of looks like that. And it also looks like I'm only doing it from -1 to 1. So really, this is restricted to that, or something like it. So really, I already know that I have a minimum there and a maximum there, and it's a global min and a global max. So that's something. But really, let's think about the steps in general. Normally, I could have a function like this. So how would I find those relative extrema? I would just take the derivative and set it equal to 0, because that's what happens at relative extrema. You get the derivative and it's equal to 0. So that's the first thing I'll do, even though I know there are no relative extrema here. I mean, some books consider these relative extrema, but I'm not going to, just because it makes more sense, because they're absolute extrema. Okay, so what can we say here? Actually, well, yeah. Let's take the derivative and set it equal to 0. So that would be g prime of x equals e to the negative x times the negative 1. I use chain rule on that. And I'm going to set it equal to 0. So actually, that's finding critical points. Those are called critical points. When the derivative equals 0 or when the derivative is undefined. So let me write that down. So let's think about that for our function. So if I said 0 equals negative e to the negative x, that's the same thing as 0 equals negative 1 over e to the x. In fact, this is never 0. So we don't get, like, this is never true. We already, like, the only way I can get 0 is if the top is 0. And this is never going to be 0. So actually, it doesn't, like, we don't have any critical points. Because also, I said this already, the bottom is never 0. So the derivative is defined for everything, for all x values. All real x values anyway. All x values. So there are no critical points for this. So then normally what we would have to do is to find the absolute extrema and then plug in the endpoints to see if the endpoints are higher or lower than the relative extrema. But in this case, we only have endpoints to check. So let's check those, because I have no critical points. Otherwise, I'd find out what the values are, what the y values are. But I don't have any critical points, so I'll just check the endpoints. And I'll do more examples so that we can see more things. Endpoints. So what am I doing? Well, I'm going to plug in my endpoints. I already know that this is my interval, so my endpoint would be, I guess it was g, right? G of negative 1. And that would have been e, I think, right? Yeah. Okay, which is like 2.7 something. And then g of 1 would equal 1 over e. And I know that there's no fluctuation in between, so there are no, like, this has to be the highest point and this has to be the lowest point. If there was a fluctuation in between, like it went up and then went back down, I would get 2 relative extrema. And I didn't get that when I set the derivative equal to 0. So these, I would probably write them out or approximate them, have decimal approximations. So those are the values. This one is definitely bigger, so it's the absolute maximum. So we can say abs max or global max of, or I would say it like this, at x equals -1, value of e. And then an absolute minimum, I'll definitely do another example. At x equals +1, value of 1 over e. And I know that there aren't any relative extrema because when I set the derivative equal to 0, I didn't get any x values. So that's my answer. I definitely want to do a different example.